has always been to create, to invent, hopefully things that are useful. And at IBM, I had a wonderful career creating things for computers. I came here, and since I've been here, I've had a wonderful time creating hybrid vehicle technology.
Having worked at IBM for 28 years, bringing technology from the laboratory to manufacturing, I did that for 28 years at IBM. That's one of the values I think I bring to this project. I know how to do that. I know how to set up the partnerships, how to set up the manufacturing facility, how to get the right infrastructure in place. I've had a great career. I had a wonderful time at IBM. I had a wonderful 28 years there. I had fun. We got to do some interesting things. Then when I came here as an industrial person, I felt the best way I could make a contribution to MTSU would be to try to get some exciting research going that would get students interested and professors interested, and also visibility for MTSU. That was my real goal. I want to, as you probably know, I graduated here with my master's in chemistry, and I really wanted others to know what a great institution this is, what a great program we have, and my goal was to do something that would give us visibility. And I think to some degree we've accomplished that. As you know, we've been on Fox News, we've been on ABC News, we're all over the internet. We've got a video out there that's had over 140,000 hits, which for a technology video it's not viral, but it's a high number for a technology video. And with what we're doing in not only the Wheel Hub and the International Partnership and where we're going with our series hybrid trucks, I believe the word will be out that MTSU is a premier place to come and do fun things that are meaningful, that make a difference. I even had some blue t-shirts printed up that I'm going to have part of when we really get going. On one side it says MTSU True Blue, on the other side it says Make a Difference. And that's kind of my mandate. I want to make a difference. I want our students to make a difference. And that's good enough for me. You know, in terms of personal, I don't know, I've had so much fun. I enjoy doing what I'm doing. I'm privileged and honored to be here as a part of this university, to hold the position I hold, do the interesting things I do. The administration has been very supportive. The provost office, Dr. McPhee, the deans, Dr. Bowles, they've always been tremendously supportive. And they just let me have fun. They let me do what I want to do. And I can ask for no better than that. I just want to say thank you that TBR, and I thank TBR because TBR had to approve my being here. All right, Dr. McPhee opened the door, the dean of the college, Dean Cheatham, but I want to thank the TBR and MTSU for allowing me for these past 9 years to be at MTSU, to give me the resources and the freedom to do the things that I really enjoy doing so that I feel I can make a difference. I feel we've touched student lives, I know we have, and enhanced their abilities, and I feel we've had a positive influence on the department, on the college. I'd like to think that I've raised MTSU's flag a little higher in the view of not only this country but internationally. People know. As a matter of fact, this international university came to us because they saw the video I made. My partners in Florida saw the video, and they came to see me, and when they saw I was doing other things, they said, well, let's do this other thing since you've already got another path for your wheel hub motor. So I just want to thank the TBR and MTSU and everyone involved for giving me this opportunity to have so much fun. My passion is to do things that I hope are relevant, that can be useful in society. I think the thing that I like to do the most is make a difference. I would like to participate in activities that help people, that help society, and as you know, we've been involved for a number of years in we call it green energy management. The students have been an integral part of everything we've done from day one. I have a long list of outstanding students that helped me build the several versions of hybrids. When we first started in this area, we built a plug-in hybrid and drove the motor through the lug nuts external motors outside the rear wheels. We put them on our little Honda. We drove it all over Murfreesboro. Everywhere we went, we drew a crowd. But we considered that not elegant. Okay, and it turns out another company in California did the same thing and got a patent on it, but we've never seen their product. All right, I don't know if they decided it wasn't elegant either. That's why we went to building the motor in the hub. But from the very beginning, I would say probably at least 15 to 20 students have participated one way or another. And the latest version, the one that's on the video, that's on the our website, I had two outstanding students. One did the mechanical engineering, the other did all the electrical part, and they really built the car. I told them what I wanted to do. I designed the motors. I told them how I wanted it done. But in truth and fact, those students who both left here and got great jobs, they built that car.
I have enjoyed a wonderful relationship with our students in my projects. In the beginning, when I first started developing the wheel hub motor, and we went through several iterations. I don't know how many students, I'm guessing somewhere around 8 to 10 students over a period of 5-6 years. They seem to want to work with me on my projects. We get along well. They learn great skills in teamwork. They learn how to do things on a budget, on a schedule, and they do some very interesting and challenging things. So I've enjoyed working with the students, and I've enjoyed seeing them go on to really some great jobs in the industry. At one time recently, I had like a list of 8 to 12 students, I don't remember the exact number, that were waiting until some of my projects would get off the ground. And I'm usually in that mode, and I'm telling them we're fixing to go, and I've got a couple right now waiting as soon as we're ready. Then they're just really anxious to work with me. Well, if you're speaking in the hybrid powertrain development for automobiles, certainly mechanical engineering skills, electrical engineering skills, I tell the students, always be a person of excellence. Whatever you do, do it well, because everything you do has your signature on it. So when you come to the task, be committed to the task, be committed to your studies, make A's if you can, do as hard as you can, and then come in and apply your skills the best that you can. Well, as Russell Chair of Manufacturing Excellence, I interact with industry quite a bit, major industry around this area. I serve on advisory boards. I visit the industries quite often. We have a great relationship with them. We try to set up internships and co-ops for our students. In the end, we want our students to be well prepared for the industries that we serve. And when I came here as Russell Chair of Manufacturing Excellence, one of the things they wanted was project management, which I developed and started teaching. And then they said soft skills. Engineers are not well known for their communication skills or their people skills. So I try to focus on that. And then when they get involved with not only my team, but other student project teams, which we have a lot in our department, they learn teamwork and other vital skills that will help them when they get to the marketplace. Well, certainly a focus that I've had from the beginning is try to develop technology that we could manufacture in Tennessee. And we have most of our work we're working on involves motor development, and there are several companies in the Middle Tennessee area that are well suited to take that over. And actually, I've talked to some of these companies, and should some of our projects really go full mainstream, then it would mean jobs in Tennessee, which is one of my motives as Russell Chair of Manufacturing Excellence. One of my goals is to increase jobs in Tennessee, and so that's always been a focus that I've had. Well, we want to hear what they want. That's why we have advisory committees, and we work very closely in all our concentrations here in engineering technology and our new mechatronics engineering program, because we want to deliver the product, the students that have the training and expertise that they're looking for. So my message to them would be, please communicate with us, participate. We invite you to be a part of the university, to be a part of our advisory council. We want to hear what you want because you are our customers, and we want to give you the best product that we possibly can. Our goal here at the university, and particularly in engineering technology, is to know what the manufacturing sector in this part of the state and this part of the nation. As you know, we are in an automotive corridor from Kentucky to Tennessee to Alabama to Georgia and even some of the surrounding states. We have major automotive manufacturers. We have a major infrastructure that supplies Tier 1, Tier 2 suppliers. Some of them are very large companies, very complex, that require computers and mechanical engineering and electrical engineering, materials engineering, knowledge of all these areas. We want to supply students that are well adapted to those technologies. I think the unique thing about what we provide here with our student projects and what I'm working on with my projects are students that can hit the floor and make a contribution right the day they arrive. That's really what we want. What we want is to make a difference. We want to make a difference not only to help everyone, but to make a difference to help the manufacturing sector in Tennessee. And our hope is some of our technologies like the wheel hub motor or the hybrid powertrain, high efficiency hybrid powertrain. We've also invented a new switch reluctance technology that we think is well suited for wheel hub motors. We want these technologies ultimately to find their way into the automotive sector. And that will bring advanced technology, and we try to expose our students here to these advanced technologies so they will be ready when they get to the manufacturing sector. This will benefit Tennessee. It will benefit by providing them a highly trained workforce prepared to go to these new advanced technologies. Well, there's several dimensions in what we're doing right now. We started with the wheel hub motor that we produced about 4 or 5 years ago, and we are into a relationship with other universities to develop and commercialize this technology. We're also looking at a high efficiency hybrid powertrain that could be applied not only to automobiles but to mid-sized trucks and also to semis. I'm very, very excited about this technology. I don't think it's being utilized by the automotive industry. I know it's been talked about, but nobody's really built it and demonstrated it. Right now, I have a truck outside that was donated to the university from a major international delivery company. I have motors in the lab, I have an engine down there, and our goal is to build this truck and demonstrate this technology that we truly can double the mileage in a delivery truck. That should have a huge impact and hopefully will open the door for many, many more applications of this technology.
A number of things here on site. Historically, we converted a bus to run on biodiesel and used cooking oil. We've put a used cooking oil processing facility over in the Ag Center. We partnered with them. They found the room, we brought the equipment, and we worked them together. Now they put cooking oil in their tractors, and we run it in a bus we modified and run around the campus. One of several green energy projects, but as you know, the one I'm most excited about are the plug-in hybrid kits that we've been working on for several years. And what this will enable us to do once it's commercialized is turn most cars into a plug-in hybrid with the addition of a kit, adding traction motors to the rear wheels, a battery and a controller, and you have a plug-in hybrid. We hope for $3,000 to $5,000 out the door. That's the goal. Whether we can achieve that, there's some other variables, but that's what we're trying to do. For a commercial product, well, in the present time, we are trying to develop an enhanced version of what I originally developed with Mr. Paul Martin, who used to work here, and Paul's a co-inventor with me of this original technology, the wheel hub technology. And we made the first wheel hub motors with permanent magnets. In the meantime, we have found that is not the best technology. I won't go into a lot of detail now, but there's a technology called switch reluctance, and we're using that technology. The problem with that is a little more complex. In the end, it will be just as economical once it's developed, but it's going to take quite a bit of money, estimated up to $2 million, to develop that into a commercial version. And I might as well go ahead and say that we are in the process of negotiating with another university internationally to develop this technology as a partnership between MTSU and the other university. We have a memorandum of understanding in place now, and we're going to go forward on this, on some contracts and more formal agreements. If that all pans out, I'm saying at the outset 2 to 3 years for worldwide commercialization, or the beginning of worldwide commercialization of the wheel hub technology. We have to develop the switch reluctance version of the wheel hub motor. We could produce easier and faster the permanent magnet version, but we feel there are some technical problems with that, And while a lot of people would want that and would take it immediately, we don't want to put a technology out there that we feel that could cause some problems. So we want to wait on the switch reluctance version before we go commercial. And as we have been trying in the last year or two to find a partner that was willing to help us with the financing of all this research, we feel we have now. There's interest on both parts. As I mentioned, we have this memorandum of understanding, and we want to go forward with this. So we're going to pursue this as aggressively and quickly as we can. Most of the components in the switch reluctance motor will be off the shelf, meaning the battery management system, the motor controllers. These are all commercial off-the-shelf items, elsewise we could not be as economical as we hope it would be. The actual motor itself that goes in the rear wheels of the car would need to be manufactured in a facility. We have an industrial partner, Orchid International, that has been with us from the very beginning. They have a plant over in Mount Juliet. If indeed we achieve commercialization, we have a tentative agreement. Not anything confirmed right now, but a desire on their part and on our part to have the manufacturing, the first manufacturing in this country, to have over in Mount Juliet. And they would retool that factory, and the motors, only the motors, the part of the wheel hub that goes actually mounted in the rear wheels, they would be manufactured in Mount Juliet, in the Orchid facility there. And it would add, I don't know, Greg, maybe 25, maybe 50 jobs. If the volumes got very, very high, maybe more. Certainly one of our intentions from the beginning was to enhance manufacturing in Tennessee, to create jobs. That was another thing we were trying to do. So in that spirit, we're hoping our partnership with Orchid International will lead to that happening in the Mount Juliet facility. Based on the interest that I see worldwide in this technology, if we had a commercial product that was economical. If this thing costs $10,000 or $15,000, nobody's going to buy it. If we can achieve the $3,000 to $5,000 price point out the door, which I'll admit is a challenge, this assumes that battery technology will continue to fall in price as it has been over the last few years. Even hopefully in the next year or two, some breakthroughs in lithium-ion storage technology. Assuming all that happens, we hope we can make that $3,000 to $5,000. So let's assume we can. The market for this is astonishing. I mean, we're talking thousands upon thousands upon thousands of applications for this technology. So it could have, at least for the local plant here at Mount Juliet, and if it really goes big, we may have to build another plant. I mean, if I just said it's wonderful, it's going everything we possibly imagined, then who knows? I mean, it might create a few hundred jobs. And then, of course, if it's manufactured here in Tennessee, it would bring revenue to the state. How much? I don't know. I would say, in the ideal sense, millions and millions of dollars. If it flies and we get the switch reluctance version and it's economical, then I think the sky's the limit. When we realized that to go to the next step in the wheel hub technology, which got all this started in the plug-in hybrid space, then we said this is going to take some time to do this. So in the meantime, while we're trying to make a partnership with another university or try to get a grant, or where we're going to find $2 million to get this work done, we think we have a path now with this partnership, international partnership with another university. Now that we have that in place, it's going to take a little while. So we've taken another path, I think equally exciting, to look at delivery trucks such as Postal Service trucks and UPS trucks and FedEx trucks. We have a methodology that we believe will double the mileage in a delivery truck on an in-town delivery, not drive around the interstate. We're talking about in-town delivery for a Postal Service truck or a FedEx truck. We believe by converting these units to what is known as a series hybrid application, we can double the mileage. Now FedEx, as you may know, has donated 2 trucks to MTSU. There's one sitting right outside. There's one over in the motor pool. We use one of them for student projects because we don't need both of them. I don't know why they gave us 2. I'm glad they did. It's very nice of them. One of them we use for student projects. They carry their various vehicles to various places in this beautiful new truck they love. The other one, we're going to take the engine and the transmission out of it and install a high-efficiency motor generator and electric traction system, and then demonstrate to the world, not just FedEx, that in this application you can get double the mileage. And I have vetted this before many authorities in the field from various locations all over the country. They agree with me, this can be done. Others have done it. So once we build one version of this and prove to the world, you can take our technology and double your mileage, then the next step, and we're also, I've got at least a verbal agreement with a local trucking company that has the bays and the expertise to start building these in low volume. As a matter of fact, we're going to build the very first one in their bay. We're going to use their tools and their expertise, and we're going to enter into an agreement with them as to their part in this partnership, MTSU's part in the partnership. So I have already the mechanism in place not only to build the first truck, but the next dozen trucks. Now, if we go beyond that, then again, it's like the wheel hub motor. The sky's the limit. If it turns out that, yes, we really do demonstrate doubling the mileage of a UPS truck or a FedEx truck or any delivery truck, you think of how many hundreds of thousands of those are in the country. And if we can do this economically, and that's the key, we cannot sell these things for $50,000 or $100,000. We've got to, for example, we looked at high volume. Our target for high volume, I'm talking about 10,000 to 100,000 units, is around $16,000 per conversion. So we feel like that's a good target, an aggressive target that we're looking for. And we're going through the business models. I have two investors in Florida that we are partnered with, two investors with a great track record. They are going about negotiating with other investors to finance this. I talk to them every week. They're very optimistic. They're very excited. So I'm equally enthusiastic about the series hybrid conversion of trucks as I am the plug-in hybrid. So we are pursuing that with all speed. Now let's just, if you don't mind me dreaming a moment, okay? Let's suppose that indeed we are able to do this series conversion and we really do demonstrate double the mileage of this technology. The next step, and this trucking company that we're partnering with has this capability, is to convert a semi-tractor to run on the same technology. That, to me, is the ultimate excitement. My dream someday is to be riding on an interstate and pull up by an 18-wheeler and look over at it and see it's one of our series hybrid tractors. That's my dream. Every time I go out and drive somewhere on the interstate, I think of the day that I want to see. Not so much that I want to have the notoriety to know that we at MTSU and our partners made a difference. We helped that happen. And the real excitement about this, now we cannot double the mileage of a semi because they're smart enough. What they have done is they run their diesel engines at the most efficient RPM at 70 miles an hour. They're designed to do that. So they're already achieving optimum efficiency for what they have, which you would expect. They gear the truck and everything such that the diesel is running at its most optimum or efficient RPM at 70 miles an hour. What we offer is that same efficiency everywhere, whether in towns, when they're delivery, when they're going up a mountain. See, we offer, this technology allows the diesel to run in maximum efficiency all the time. And what I think is really exciting is someday, I believe large cities like Chicago and Los Angeles and New York are going to pass a law, are going to force trucking companies to be electric when they come in the city. Locomotives already have to do that. They've had to do that since the 30s, okay? That has been well known. In New York, locomotives switched to electric about 15 miles outside the city. In the old days, steam engines had to switch to electric. They'd take the steam engines off and put electric locomotives on them to bring them in. Well, that same thing is going to happen with semis someday and delivery trucks. That's a prediction now. That's a Perry prediction. I don't know where it's going to happen. We want to be ready for that. We want to try to develop the technology. So the evolution of what we're doing is we're gonna start small with a little postal truck. These little postal trucks we run around town, we're gonna start small. Then we're gonna graduate to the FedEx style truck and demonstrate it there, assuming success each way, and each way has commercial application. The very small trucks, the mid-sized trucks, and then use that to leverage to get the funds, because converting a semi-tractor is a whole different world. You have to have about 75 to 100 kilowatt hour battery for a semi-tractor to run about 10 to 15 miles, okay, on full electric. For example, a Nissan Leaf has a 24 kilowatt hour battery, just to give you a feel. So you're talking 100 kilowatt hour, 4 times the size of a Nissan Leaf battery, and in a semi-tractor, that's only going to be good for 10 to 20 miles, which may be enough. That's enough to get you up a mountain. That's enough to get you in and out of a city. So to me, all of these things contribute to efficiency, to reducing carbon footprint, to reducing our dependence on foreign oil. That's the goal of all of this. The $2 million that we're in partnership with this international university is only for the wheel hub motor version, the plug-in hybrid kit for cars. And anticipating to make the very first least complex postal truck is going to take about $100,000 to $150,000. That's pretty easy. My investors tell me that's not going to be a problem. They feel that's easy to do. To convert a FedEx-sized truck prototype's about $200,000. To do a semi for the first prototype is about $500,000. Now, we're still not talking big bucks, but to commercialize is a different process. Let's suppose we want to commercialize the FedEx truck. That's going to take $2 to $3 million of tooling cost, because Orchid International has given us prices for these type of motors and high volumes that go in the FedEx truck, and they said we're going to need about $1 million tooling just to tool the factory to build the motors. Plus the fact we have to modify the batteries, develop control systems, control algorithms, set up other manufacturing facilities. So to go manufacturing for either the postal trucks or the FedEx UPS style trucks is going to take several $1 million. Now, my Florida investors, that's what they want to do. And they have an international distribution system already. They're in the tire business. They have distributors in Japan. They have already got a person in Japan that, if we prove this technology, will distribute it in Japan for this company. And we already have an agreement with this company in place that's been signed off by the university. So the next step, the Postal Service or the UPS, when I see that we're ready, all right, to start building this at the trucking company that's about 5 miles away from here, the facility. We don't have a bay here that's big enough for me to park a FedEx truck in and tear it all apart and work on it. So that's why I had to go out and find some space elsewhere and get someone interested in working with me, which we've done. So when we get to that point, then I will have to have students. I will be using Rick Taylor, our lab director here, and John Roselle, our associate lab director. John's a part of my team. John is very expert in CAD and CAM and design. He's already building a motor generator set in the lab. He's got already built a beautiful setup there in the lab. So I will be needing students. I will be needing our staff. I will be using, as I have in the past, some of our professors. Dr. Chen advised me on the wheel hub motor, so some of our other professors will be involved in this research. So we will be as involved here in engineering technology very extensively with students and professors. To me, the significance of this research is to make a difference, to help all of us. All of us, I believe, in this business of engineering, technology, science, we hope that we can take what we know and our ability to help society, to help others. How do you do that? Well, give them an automobile that runs on less fuel, more efficiently. Help us by not having to depend on foreign oil. Help us by not polluting our atmosphere and polluting our rivers and streams with these fuels that, yes, have been good, and I'm glad we've had them. I enjoy it. But we have to go beyond that. And to move in a direction that's green or greener, that is my passion, to try to bring hybrid technology, efficient technology. One of my goals is to more efficiently use the fuels we're already using. Okay, we can't run everything on electricity, but if I can get twice the mileage out of the same gallon of fuel. See, one of the things I like to think about, let's suppose someday that our mid-sized trucks really work and we double the mileage in a truck. That means 2 trucks will be burning the fuel of 1 truck. That's almost like taking 1 truck off the road, see? And to me, that's exciting. And 2 trucks, they send out 2 trucks and burn the same amount of fuel that 1 truck used to burn. That's good for the trucking company, that's good for the environment, that's good for everybody. And that's my goal. And with the plug-in hybrid, it's the same thing. If around town we can enhance the mileage 50 to 100%, and a significant percentage of the cars, that's going to reduce fuel, that's going to reduce emissions, that's going to save people money. That's a good thing, and that's what I want to do. You don't know that the kids get over here in 170 and just live there and build all these amazing things and go out and compete against other big-name schools and beat them. Oh, actually, they line up to work for me. I have a list of about 20 right now, and I can't hire them all. Be anxious to see, not anxious, but interested to see what you come up with.